Okay, we're about ready to get started here for design review, or I should say design review experience, right? Steve Fox and I have a few things to talk to you about today for about the next 45 to 50 minutes, and then we're going to let you know who the final winners are for design and so forth in this deal as well. So everyone out there is going to miss out on the opportunity, and we'll cancel their YouTube subscriptions so they can't see it later. As we know, this has been a kind of an interesting, somewhat troubling time over the last 2.5 years for you teams getting your act together for building a car, building your team, trying to go to class, everything else. So, as we said for the May event, I just want to reiterate, you all deserve a round of applause for getting your butts over here to this competition. There's an old saying that the race starts at 1 o'clock. If you're not here, don't worry about it. The race starts at 1 o'clock. You all did very well just to be here. Consider yourselves winners just for the fact you made it here. There's a lot of teams that gave up and couldn't make it for whatever reason. But a lot of times it's a matter of poor organization and communication on the team. And we're going to discuss a little bit of that today for you as well. I'm going to show you some stuff that people who are old-timers in design and product development understand, but you'll be really at an advantage to kind of get a head start on some of this stuff. So Steve Fox, obviously, longtime design captain. Okay, he's been, covering this for quite a long time. I mentored under him, and he's taught me one heck of a lot about how to deal with all this competition nuances. So I really thank him for being part of this still, and I hope to have him around with us for many more years doing this. Steve, any other comments before we get rock and rolling here?
I'd just like to say welcome to Formula SAE Michigan, the second mission, or what Dave and I call MI2. It's pretty nice to have electric cars here in Michigan, and I'm sure that you all had a great time being here. We enjoyed watching you here. One of the greatest things I like about Formula SAE is that there's no two cars alike. In my day job, I deal with cookie cutter race cars, and it's dreadfully boring, I gotta tell you. There's no boredom here. You guys see to that. Thank you very much for your participation. I enjoy watching the cars and the top 5 or 10% of the engineering collegiate students in the world, and it's fun to watch you all work.
Before we get to our first topical area, one sentiment from the vast majority, if not all of our judges, was that your attention span when we gave feedback was phenomenal. And we don't always see that, and we like to keep seeing it because we want to give you whatever information we have. And there again, keep up that, because that's how you keep learning and getting better and better and better into the future. Okay, first thing we're going to talk about is a topic called compliance. Okay? Our parents always told us, to follow the rules and do this and do that, and if you didn't do it right, you'd sit in the corner or whatever the penalty would be. The vehicle has all kinds of issues with compliance, as do teams. So physically, the most common ones that we saw in your cars were in the suspension, some issues with regard to the seat, in terms of you moving around in the seat, not strapped in properly. Steering, I want to talk about that one quite a bit. And pedals, which I think is a pretty critical one as well. Steve, you want to mention something on the suspension part?
We see all kinds of problems with suspension, and compliance is the number one leading problem that we've got. The toe base on your rear wheels has to be as wide as you can make it. The links that you use, the rod ends, any of the components you have bolted in have to be in top-notch, first-rate condition. They can't have any play. Professional race cars change these kind of components out on a regular basis because you just can't tolerate play in a steering or a suspension system. It's critical to the performance of the car. This year we saw our share of rod ends and bending. Any of you that do not know what rod ends and bending are, come and see me after this competition. I will tune you up. I wish that rod ends and bending would be banned from Formula SAE forever, but we still see teams show up with rod ends and bending every year. This year is no exception. I'll also talk about the seat. There's a fair amount of cars here that have seats that are padded. And I've gotten a whole lot of conflicting answers from students this weekend telling me that the seat doesn't have to be comfortable, or we've been told that the seat should be painful and it shouldn't be a comfortable car to drive. Well, I've got news for you. If you get any kind of a design judge that makes that statement to you, tell me who he is, and he won't be a design judge anymore. Your seat should be molded to your backside as well as you can possibly make it. Now here's just one recipe for how to do this. Take urethane foam, throw it in a plastic garbage bag, toss it in the car, get into your skivvies, no extra layers of anything, sit in it for a while until the urethane sets up. You've now have a mold of your personal posterior. It's the world's best conforming seat that you could possibly make. Take your foam seat, take a plaster cast of it, or make a fiberglass cast of it, or make some kind of a cast of it. From the cast, that's your tool that is your back end. It's a tool of your back end. Can we call it a back end tool? We could. Put your layers of fiberglass or carbon fiber, or whatever, choose your material that you want to use. Make your seat from your back end tool. That's now your seat. When you add fire-resistant underwear and your driving suit, it's going to wedge you into the seat. It's going to be very, very comfortable because there's no hot spots. There's no pressure points on the backside whatsoever. You're going to make the seat come at least halfway up the side of your torso so it's got extreme lateral grip. and it's going to be personally fitted to you. If you've got another driver on your team that happens to be your size and can share that seat, all the better. If you've got drivers that are 3 or 4 different sizes, make 3 or 4 different seats. Put them on Zeus fasteners so they bolt in and bolt out. Put the right seat in for the right driver. There you go. That's the world's best seat. I was taught this by an art student from Cornell quite a few years back. Cornell was smart enough to bring art students on board onto their formula team because art students think with the other half of the brain that we don't so much use. They're free form. They're all about curves. Think about what the shape of your backside is. There's not a straight line on it. It's all curves. That's why you have to do a mold of your backside to get a proper seat. Your seat should not have any cushioning on it in any way, shape, or form because the cushioning is compliance. When you go to step on the brake pedal really hard in an emergency situation and you compress the foam in your seat, it's compliance. It could lead to a problem. So just one little critical component like a seat seems like a simple no-brainer, and we see a lot of different solutions for seats. A lot of them are really bad. Only a few of them are really good. I wish you guys would get a whole lot better at making really, really good. Dave?
One other thing about the seat, or 2 other things. The seat is compliant. If it's more compliant than it should be, that's just like loosening up your safety belt. Because you're moving rearward and downward typically, and that's just like loosening up the belts. So whenever we hop in race cars, and believe it or not, Steve and I used to race quite a bit, you hop in, you cinch the belt down, and then a crew member comes down and cinches it down even tighter, and you say, oh, I can't breathe. And by the pace lap, by the 3rd corner, you suddenly feel like you've got compliance all of a sudden. Part of it's the seat is moved, part of your body's compressed, and the kind of cushioning in your skivvies, your long underwear or driver's suit is all compressing as well and displacing. So things loosen up over time, or at least that's the feelings that it's loosening up on you. And then you don't have good control of the car. And that's the other thing, if there's compliance in the seat, your rear end is actually a very good sensor to tell you about G-forces, tell you about vibrations that are going on, and also those vibrations go through the rest of your body, and you feel it in your inner ear as well. If you insulate yourself from all that, you now have less capability of seeing and feeling how that car is. So it's not just something to hold you in place, as a lounge chair. Although you make it comfortable, like Steve said, and firm fitting, you may want to sleep in the car sometime. I want to talk about steering a bit. Every car I went to see since Thursday morning, actually since Wednesday afternoon, one of the first things I do is I go over and I wiggle the steering wheel. And of course you make sure that the steering wheel is on properly, the hub. But a lot of them, it feels like it isn't on properly, even though it is officially on. If you're moving that steering wheel and this front wheels are not moving one bit, how well will you handle the car at the limit? The limit is not, I'm talking the maximum G-force of the car, which you all know about friction circle, the GG diagram, or those of you who have enough downforce, the GGV diagram. You're trying to push the outer limit. But the limit is not a nice flat ceiling. It's like stalactites hanging down. And your job is to go push through those and find that limit. And that means rapidly moving the wheel back and forth. Sometimes we call it wicker steering, it's a driver training. We're actually pushing it through a super high frequency sawing of the wheel to try to explore that limit. If the wheel has 3 or 4 degrees of compliance in it, good luck. Okay, you're always out of phase with it. By the time it catches, you're still moving the wheel over, and now it comes back the other way on the G's. You're reduced, and now you've gone too far, and now it's a compliance the other way. So keep that quite tight. The whole rest of your suspension has some compliance in it as well, and we try to minimize that up to the point where we don't have a whole lot of friction in the system where it won't physically move. But so the steering there is a very important deal. Also, there are some cases where if the steering rack in particular has compliance in it, that is working towards a failure mode, and you can see failures that can occur. And if you think driving with a stuck throttle and no brakes and no clutch, which I've done in some of the old race cars we used to run, imagine driving with no steering. give you a whole new appreciation of being very scared. Related to that are the pedals. I kind of mentioned the brake and the throttle and the clutch. Most of your cars are turning into two-pedal cars because you're discovering the ability to do the electric or hydraulic upshifts, or pneumatic upshifts, in some case electric upshifts. That's neat because you can do a decent amount of relationship between the throttle and the brake. You can release the throttle and apply the brake at the same time rather than moving your foot over. I mean, I left foot brake with my street Suburban, so I'm used to left foot braking. But if the pedals have a whole bunch of slop in them, and usually it's down at the lower fulcrum of the pedal, now you have issues of that not being consistent, and worse, you can have cases that can get caught up. If you've got a bronze or even any kind of a polymer bushing, you can have cases where you can get into a certain angle and it will not return. And that is very scary. You don't want to have that happen, and it's very dangerous. We don't have that happen. Don't rely on just the over limit switch for the brake pedal. Realize in a lot of cases your throttle can go down and, oh wow, I had enough compliance, and now the pedal, which was, about 3 millimeters away from the frame, is now under the frame. You don't press the pedal squarely down, although we'd love you to do so. You usually put a certain angularity to it, and you shove the pedal outward most commonly, particularly for the throttle. And when you put your throttle so close to some frame members, which I saw in a number of vehicles, you're just asking for trouble. So the idea is you want the car to survive so you can survive. And do not let yourself fall into that trapping of, well, it's pretty good. Well, we just wanted a bunch of looseness in there so that our brake bias will work properly. As engineers, you should be looking at what amount of compliance is appropriate for the brake balance to work. Too tight in that region with the balance beam is in fact a problem, but too loose, you've got all kinds of these compliance issues with regard to sensitivity as well. So we could go on and on about brakes, which is limited time here, but just from the pedal point of view, safety first, and then focus on the performance, of course. Comfort becomes a bit of an issue as well. It's very common, even in a lot of race cars, to have little cups for your heels, or at least a little ledge for your heels to sit on. If you try to press with the ball of your feet and your heel is floating, you're going to have a lot of fatigue in your leg, particularly if you run longer races. Okay? I don't know how many of you are going to go run 2.5 or 3 hour stints like they did at Le Mans last week, but I assure you, having pedal cups or some method of restraining your heel is actually a lot more comfortable and helps you avoid cramps and so forth with your legs. Okay, the other part of compliance is administrative compliance, our favorite thing we love to talk about. I know it's been a difficult time, but that doesn't mean we should be submitting our documents late. This year, we'll show it, it's down here. We had, believe it or not, an unprecedented number of penalties. I don't like that. I don't want to give penalties. I'd like to give 0 penalties. We saw templates that were turned in that didn't match at all. It was using the old design report style that we gave up on in 2020. We saw design spec sheets which were blank. How many of you spent more than an hour or so working on your design spec sheet? Probably every one of you spent 10 or 15 hours trying to get that right. If some team doesn't even give the consideration to put that in, what score should we give them? Right? It's not fair for the rest of you when they do that. It's not fair for the judges as they're going through trying to look at it. A number of them didn't have your name on it or your car number on it. We're going through, when we first start, we have 110 or 112 teams. As of 2 weeks ago, we had 103 teams. We don't sit there and do it all on the computer. We're looking through a lot of it hard copy because we got jobs, we're off on the road, and we're always sitting there looking at our phones or our computer all the time. A lot of times we look at hard copy. And if we got something which is the basic template layout without any identification of what school is, guess what? You're not going to get reviewed properly. So we did give you some penalties this year. It's very rare that we do that, but we feel you really need to understand how important that is from our perspective of reviewing your documents. But also, if you're going to be having your documents archived for future use, you want to make sure that it's all done properly too. So it's not just about us, it's trying to make it better for you to make your teams better in the future. And I'll tell you what, you do that in business, you'll be finding another job pretty quickly. Okay, so be diligent about that. Being casual, that was great. when we're in high school or early parts of college, but as you get into industry, you got to be serious enough about that, okay? And I'm not Mr. Paperwork guy. I'm just saying that these are technical documents that we should have the proper information as to who you are. That goes for your 3-view drawings as well. We had some 3-view drawings. There was no indication of your team on the drawing anywhere. Not even a student name, not a phone number, no nothing. Are we just supposed to know based on the body shape? Well, that looks like it's from this particular team. Okay, so that's important. The other thing is, we've had quite a few cases. We saw problems where you have difficulties going through tech because you hadn't read the rules thoroughly or gotten clarification. And it's possible to go ask for clarification well advanced in the competition. Now, a number of you teams that had continuity of students who have been with you will say, yes, you can contact the rules or the tech area through SAE, and they have a whole forum for that. You put in your request, and they'll respond to you. Every now and then we're asked questions that came from that forum, and usually they're very prompt to giving a response. I understand you didn't have the pleasure of that knowledge at times for a number of your teams, because the person on your team that knew that may have graduated last year or the year before. But now you know, it is possible to get feedback. Read the rules first, but also, if you have questions about them, get the clarification early on in your design cycle. Okay, structural. Steve?
I talked about rod ends and bending, so I'm not going to mention it anymore, but honestly, if any of you don't know what it is, I've got photos I can show you tonight. Nodal analysis, it's pretty basic. You need if you're doing a tube-frame chassis, you need overlapping tetrahedrons. That's what it's all about, and their strength and triangulation. Your SES has been simplified greatly. We've poured a lot of effort into getting the SESs reviewed in a very, very timely fashion. And if we see an SES that comes in with mistakes, we get it right back to you and explain it to you, and we try to make it as easy as we can for you to get through the SES process. Tub versus tube. There's no right or wrong answer on whether you're doing a carbon fiber tub or a tube frame chassis. We really don't care if you do one or the other. We have no preference. Both answers are right. But if you supply one or the other, do it to the best of your ability. They've both got to be strong. They've got to be rigid. They've got to have a certain level of minimum torsional rigidity to them. If you don't understand this, ask questions. Ask questions of your senior team members. The best source of information for something like this is from design judges. So if you have questions about how to do something, when you get your design review briefing here at the competition, ask questions. We'll be more than glad to answer any questions you've got. Composite versus metal is also the same category. There's a lot of teams here that don't have an unlimited budget. And for the ones of you that don't have an unlimited budget, you're going to be dealing in other materials other than carbon fiber, and there's nothing wrong with that. We raced with steel and aluminum for a whole bunch of decades before you all came along, and we did pretty famously well with it. There's nothing wrong with that solution. It can be made to work. If you have the budget for composite materials, knock yourself out and use it. Just be sure of what you're doing, because you've got to get the laminations correct. You've got to have it manufactured properly. You don't want the structure delaminating on you, in mid-race. Both materials can be made to use. We don't discourage the use of one or the other or discriminate. So whatever you've got for your budget, we're more than happy to deal with it. The other thing that we're seeing lately, and we saw an awful lot of that this year, is simulation is not validation. So on the score sheet, it takes a number of different subcategories, and it talks about designing, testing, and validating. There's no substitute for validation, which is actually putting it on the car and trying to break it. So I understand that there's an awful lot of students that are really enamored with simulation, and that's fine. You can simulate a whole lot of stuff and save yourself a boatload of time doing it, but it's not a substitution for actually breaking apart. Just understand that and understand the differences. Dave?
Hey, we know you're not planning to be plumbers, but you do plumb the car in a lot of different subsystems. Okay, the brakes, obviously the brake hydraulics, in some cases the linkage for the brakes, in some cases as well. Coolant lines, that applies obviously to the EV cars as well, proper routing of the lines, making sure they're not going to get broken, or I should say cut, or damaged when one of you work on the vehicle, or put it in such a spot you put a jack and all of a sudden it gets hit. Or the classic is you got a flat tire and a number of your lines are scraping on the ground. I've seen professional racing teams do that too, by the way. Big mistake, of course. How often do I see your fuel tank less than an inch away from the exhaust? Oh, we put a little bulkhead aluminum piece, sheet metal between. Unless you're deliberately trying to preheat the fuel, not a great idea. Not so much from a performance point of view. We can talk about heating up the fuel to evaporate differently and so forth. But what about when you have an impact and things crash into the fuel tank for the backside, meaning the motor, you get a rear entry crash. You're going to go right through that little sheet metal. Now you've got a hot exhaust. The surface of that exhaust is probably upwards of 650 degrees on the outside. Going right into the fuel tank with a flash point, it's going to be down at negative 30 degrees. What do you think? Auto ignition is about 700 degrees for most fuels. Okay? Keep the fuel well isolated from anything that's going to get that hot. Okay? And we're not doing a deep dive in it today, but the idea of FMEA, get an idea of failure modes and what effect that will have. Analyze that. Okay? Don't think about just for the performance when the car's intact. Think about what happens when you crash it. Not if you crash it, but when you crash it. Okay? We don't want you to crash out here, but things do happen, and statistically, every year there are teams that crash and do enough damage to the car that they've got to start over with the frame. Luckily, in most cases, they haven't had a catastrophic situation, but worldwide, we do see that every now and then. Okay? So think from that safety point of view about what's going to happen when things go wrong. Okay? Control cabling. We see kinks in the control cable. I'm calling that part of plumbing, if you will. But the cabling, for the throttle cables and so forth, and sometimes for clutch applications. The seat sits right on it, and all of a sudden it's pinched. Or it's been wound around in a loop, and then you go to move it, and the whole loop is moving a little bit. You're losing the sensitivity there. Remember we talked about the steering sensitivity, if that's loose. If you got a situation where your throttle was floppy around, that's not very good either. Okay? If it is too tight, when you get rid of the compliance, then you probably have the wrong kind of cable you're using. Okay? Cables like that, Bowden cables, are usually not something you want to go buy on the price. Go try to get the best one you can, the best specification. Some of the aircraft-based ones are expensive, but they're actually quite durable, and you may want to take a good look at that for certain critical applications. Okay, I'm a big electronics integration guy. In fact, I'm probably largely responsible for part of your score sheet that talks about systems integration and electronics integration, just because you guys were all doing a lot more of that, in the mid-2000s and onward. One thing I harp on is harnessing. I'd like to see that harness, actually no, I don't want to see that harness. That harness should be invisible in the car. Put it under a panel, put it someplace where it's not going to get snagged. Drivers and mechanics regularly remove one thing and there's a harness piece in the way or a sensor lead, and it gets broken off, okay? Then it doesn't work. Well, if it's passive data logging, okay, you get along with that, that sensor. But increasingly, you're starting to integrate your design where the brake pressure is being used to turn on the brake light or to turn on do some work with regard to the ECU. Particularly for the EV cars, it's becoming a bigger issue where the controls are interfacing with your control units. Pay attention to the harnesses. I like to say they should be perfectly invisible. You can access them when you want, but otherwise you don't even realize they're there. Okay? If you look at the miles and miles and miles of harnesses that are in your typical street car, and you hardly ever see the wires. It's tucked under the dash and the carpeting, but even there they got bolsters covering things up, or in the engine compartment they got a whole engine cover there. It makes it look pretty for their marketing purposes, yes, but it also helps protect those harnesses as well. So take your idea of keeping it invisible. That's largely true for a lot of the other systems as well. You don't want to see brake lines sticking out. I just had a historic Alfa Romeo I was working with last summer. The brake line was right behind the wheel on the right-hand side. Rubbing Actually, not right behind. It was next to the wheel on the outside of their framework, and the tire was actually rubbing against the brake line. And one of the guys was like, "Well, it's rubber. It's not going to hurt the metal." And you can see it's worn through almost all the way. Okay. I had some photos I took yesterday of some of your cars where your wiring was right behind the exit of the wheel. If you go run off-road or you go run in the rain, what are you doing with that wiring? It's just a cluster, just trying to catch every remnant and small animal that you run over. It's going all right into that wiring. Okay? So anticipate the worst. If it's going to break, it will break at the worst time. So be aware that Murphy is alive and well in your car, and don't let Murphy in.
All right, I'll talk to you a little bit about powertrain. And because we've got IC and EV here, we're going to not discriminate. We'll give equal time to both. Any engine can be made to work, but you got to select the right engine. So our 3 design finalists that are in the top 3 in IC happen to have 3 distinctly different engines. One's a 3-cylinder Triumph, one's a 1-cylinder Yamaha, and the other's a 4-cylinder Yamaha. 3 distinctly different engine architectures. The team selected those engines specifically for the type of car that they built. They had a strategy to earn points, and they maximized the car, chassis, frame design for the particular engine and the power output curves that those engines give. So when I say that any engine can be made to work, that's a true statement. You can give me anything and I can make it work in a race car. It's just a matter of how much time and effort it's going to take to really get it to work properly. But when we tell you to go ahead and select the right engine for your goals, that just takes time out of the whole thing and makes your job a whole lot easier. So do a little bit of research ahead of time, figure out the differences for your IC types as to what kind of a different power curve you get with a single, a triple, or a quad cylinder engine, and adapt it to your best point getting strategy. After all, this car that you brought with you is just a point getting machine. Its sole purpose in life this weekend is to earn points, right? You should have a strategy to earn points, and that car should be maximized to do that, and engine selection is a big part of that. When you select the engine that you've got, baseline the engine. I can't tell you the amount of times that I've talked to engine engineers in the Formula SAE series that talk to me about, oh, modifying this compression level and putting in this set of cams and advancing them and all the different fun things that you guys get to do to engines to improve their performance. When I ask you, did you baseline the engine, I almost always get the deer in the headlight look, why would I want to do that? Or they rely on a Google search that gives you the stock engine specs for your particular engine, because after all, these engines are used in a wide variety of different recreational equipment. Do the engine specs that are published match the engine that's in your car? Usually not, because they don't use a restrictor and you do. You're required to put a different intake and exhaust system on your engine that you build yourself, and it doesn't perform exactly the same way as the stock exhaust and intake that's on the engine to begin with. Baseline your engine. If you've got a dyno at your school, there's just no substitute for knowing where your starting point is. Then you know where you're going. Put on that header, you're either going to gain power or you're going to lose power, and the dyno is going to tell you if you've got a baseline run. Justify all your mods. So when we talk to you about all the trick things that you did to your engine, I want to know why you did them, and that you can actually justify all the work that you went to get the engine in the condition that you have it. I don't want to hear stuff like, well, I looked in the catalog at the local motorcycle store, and they had these trick high compression pistons, and they just sounded really awesome, so I knew I had to have that in my engine. That's not the answer. That's the answer I get out of backyard mechanics that don't have a degree in engineering. That's not where you all are headed. You aren't the backyard mechanics. You all are destined to be the engineers that create the parts for the OEMs or the aftermarket, and you have to know that stuff inside and out. It's just that simple. All mods must work in harmony. On an internal combustion engine, the intake sizing and plenum size works in close harmony with the cam timing, the head design, the compression ratio, and the exhaust system. You modify one, you will probably need to modify the other parts in the system. They all work harmoniously. I can't tell you how many times we see students that come with just a header and just an intake design. They don't have a real good comprehension of what the cam timing does or why, and why that cam timing works with that particular compression ratio. It's all a big harmonious package. So make it all work together, make it all happy. You'll have a much better result if you do that. I'm going to turn this over to Jacob Overland. We were fortunate enough to have him on board. He's going to talk to you about EV.
Yeah, thanks, Steve. So to start, I want to echo what Steve said on the combustion side, but even more so. The electric series, you guys have an almost limitless amount of options when it comes to the system design for the vehicle. So I think one, maybe two teams in the history of the series have made their own combustion engine. Every team out there that's doing EV is making some component themselves of that system. So don't limit yourself. The thing that I want to call out for the system level design here is I saw some teams this year saying, well, we have this inverter, or we had this motor, or we had this whatever. So then everything else in the system was selected based on the limits of that one specific component. Don't limit yourself like that. Especially for the electric series, it's wide open. Take advantage of that. Obviously, as judges, we're going to dig into that. We want to see that system level thinking. Along those lines, the accumulator is the thing that I saw pretty much every team out here made themselves, some component of it, pretty much all of it. When you're doing that, you really need to think about manufacturability, serviceability. Keep in mind the rules constrain you to how and when you're able to work on that thing. If you need a bunch of tools, if you need a bunch of safety equipment, it makes it a lot harder. So really, really think about how do you manufacture the thing, and then how do you service it. I know that a few of the teams that didn't finish endurance out there had problems inside their accumulator, and obviously you can't work on it when it's out there, but if it's some other part of the event, you want to be able to get at that stuff. Something else to think about is I think all the teams did a really good job of just kind of first order, here's how much energy we think we need for endurance. That's how we design the capacity for the accumulator, but it's not just about capacity. You also need to be thinking about the state of power at the end of endurance. If you're basically riding the voltage floor limit, the driver is going to really have a hard time with that if you're limiting as you're coming around on the last lap or the last couple of laps, either due to thermal reasons or energy capacity reasons. Really think about what the state of power is at the end of drive, just like at the beginning of drive, and what the drivability of the car is like. Same goes for regenerative braking if you're using that, but it's the opposite, right? You don't have any regen at the beginning, presumably because the pack is fully charged, but you do at the end. And so what does that do to the drivability? And then the last thing that I want to harp on is the thermal performance. So the rules are very specific in terms of 60C limit. I think all the EV teams know that, but that is by no means anything to do with performance or like a guideline for how you should design the car. Obviously you have to stay within the limits, but I really want to make sure that all the EV teams really think about for next year how the temperature measurement works within the pack. Again, 10 millimeters from the cell, there are so many ways that you could be very, very far from the actual temperature of the cells in the pack, and understanding that is super important to the performance of the vehicle. Even to the point where one of the finalists out here made the decision for a pouch cell that they would rather have the ability to get airflow around those pouches than put pressure on them as is typically done to get a little bit more performance electrically. So I'm definitely not saying that is the right answer, but it is a question that you can ask, something that you can think about. And if you're able to control the temperature of the cells, you will drastically change the performance of the accumulator. So I really want to see teams think about that and not just doing sort of a meet the rules. The temperature sensor was close enough and we have enough of them to get by. Super important.
Thanks, Jacob.
Thank you.
Thanks, Jacob. Thank you, Jacob.
The mic is on. Thank you, Jacob.
Hello. Let's talk about integration. Ethan.
Okay, I just want to mention, Jake had mentioned temperature. Temperature monitoring through the whole vehicle obviously is very important, and the more you look, the more you see, you realize how you've measured is every bit as important to your conclusions as what the generic scalar measure was. There's another thing we talk about with drivers. There's two different types of temps we worry about, and that's temperature and temperament, and that's called keeping your mind under control, what you're doing here. Engineers are usually pretty good about not showing too much of their emotions until they start looking at the electrical integration part of the whole car. We've seen a lot of different modules that are coming into the vehicles, okay? Geez, when we did this 15 years ago, it was all about CAN. It was a big deal. Now we're seeing power distribution modules. A lot of you are making your own circuits from scratch. And it's good. I like to see you're doing that. We're not looking for toys to be on there. We're looking for actual something that's going to help the vehicle and help the performance. The concern I often have is a lot of the modules that I see being built or bought and added in, there's a whole question of make or buy there, of course, right? You buy something or do you design it. It's how well do they work together with other parts of the system. So in a few cases we see, well, we built a PDM, power distribution module, and it didn't work, so we couldn't really get the car to run. What was the contingency plan? Why wasn't that worked out ahead of time? Why wasn't there not a redundancy or an easy way to handle that? The more items you put, I'm going to put some slides up a little bit later about this whole concept, but the more items you put on there, the more complicated you make the whole management of it. If you're going to do these different subsystems, you need to pause a bit and think about how they will affect each other, okay? It's a big deal to be able to understand what happens in each of those areas, and not just when they fail, but if a sensor goes bad, what effect does the controller do? Early days when we started having electronics on the engines for electronic control units, we would have a lot of runaway conditions because a sensor reading. So then what we had is we had traps or settings that would say, okay, it goes beyond this value, it's got to be an impossible value because that sensor normally doesn't do that, but an open circuit creates this voltage of 5.0 volts or down to 0 volts. Most sensors might have been from half a volt to 4.5, for instance. If you exceed those limits, then it just goes into default value. And it says, okay, your temperature, no matter what the sensor really reads, the ECU doesn't believe it, and it says, well, you're actually 160 degrees. And you look in your data, and it's always at 160, that's wrong, but it also is an indicator that it's trying to get the engine to run right, even though the sensor is malfunctioning. A lot of you haven't done that when you have a sensor or other subcomponent fail. The system can sometimes override that a little bit, by being a little bit smart about how you program. And that's true for power distribution modules, which are wonderful tools, but a lot of the other controllers you have, think about how will you keep the vehicle running, bring it home through endurance, even though it only has 75 or 80% of the power, okay? We talked a little bit earlier about integration, the seat and the accessories. Really probably mentioned as much as the seat is really the whole instrument panel. When you're really driving hard, there's very little time you have to look at your dashboard, right? You're looking out, how many cones out are you looking? 1 cone, 2 cones? No, you're probably looking 6 to 10 cones out at least for the corners, and for long sweeping corners, maybe even further than that. When you're out there looking out 100 feet, or you usually try to look out at least a second or two ahead, 2 seconds if you can, depending on the speed you go, your field of your focal point is so far out there to come back and look, 20 inches away or 25 inches away doesn't work well. So individual digits on your dashboard, unless they're monstrous, and it's a single thing that's simple like a gear indication, are almost useless when you're really at the limit. It's okay for testing. You're riding the brake deliberately while you're doing loading and you're doing a straight line. You can look at the dash. But when you're really in the heat of the moment, forget about it. I've had a driver, one in particular, tell me that his oil temperature, his oil pressure was 30.4 psi, which is interesting because we don't show it in 3 digits. It only goes, to 2 digits. So sometimes drivers will lie. Maybe not intentionally, but you're convinced yourself that something happened. Much better to have the data recording, okay? When it comes to the accessories with regard to the dashboard, often less is more. As long as what's there, it's critical that you're being able to get notified of it. The more you put on there, that looks great. People take photos of it. It's a color dash. And you got these lights over here and this and this. And these little knobs I can switch around. And a lot of you, I'll ask, what does this do? And you'll say, I don't know, they told me not to touch that button. Okay, but why is it there? You give an engineer something to fiddle with, they're going to fiddle with it. That's the reality. I mean, go get a rental car. Every one of us will push the limit on that car in a variety of ways. It didn't happen this weekend, though, so. Not yet, I haven't got home yet. Same with frame, aero, and suspension. Your wings affect your chassis. One of the teams here had their front wing in particular affecting the unsprung weight as compared to the sprung weight. So it's going directly onto the uprights, or actually below the spring perch, but through the unsprung side. That's pretty neat, right? Because then when you roll and so forth, the wing doesn't move over, okay? But there's other interesting scenarios. You got a lot of other appendages necessary to make all that work. So you got to look, is it just interesting, or is it actually helping the performance of it, okay? Anything you do, you have to understand how they work together. The aero goes right to the frame, and ultimately the suspension is going to the frame. We talked earlier about the seat is going through the frame. You're going through to the frame, and the seat rather. It's all connected, okay? And it's all too common to develop in one area and then not be mindful about how other people on the team have been doing their work. And in a second, I'm talking about feedback loops. We're going to see that can be catastrophic in terms of cost and time in your design process. So understand, you don't work in isolation. You're working on a vehicle with a whole bunch of different subsystems on there. Steve, got a comment about that at all?
No, let's keep going.
Okay, communications on the team, critical. In some major automotive establishments, they have actually built their buildings in somewhat a shape or a location of the different employees based on what they work on. So the teams, sub-teams working on central dashboard, maybe somewhere central in the building, and the powertrain and transmission areas are adjacent to the engine, okay? The idea is you could go down the hall and talk to them and show them your drawing or your discussion about things. The idea, well, I text message them or I sent them an email, that should be good enough. You don't have that feedback. You went through the Zoom thing over the last couple of years. Feedback isn't that great doing those types of virtual reviews. Are they neat technology? Can you make use of it? For sure. But it's no substitute for at times being face-to-face. Also, as a team, part of that communication is getting to know each other very, very well. Know what your hobbies are with each other. Why are we doing that? It's just a social club. Well, you might find that a particular member of your team understands something that you didn't realize he understands or she understands, okay? And you may say there's a certain bonding there. Say, hey, you're into, you flew kites or did, small aircraft or something like that. Well, they might be really good at doing sub-assemblies on wings or something like that, okay? So understand more about your teammates, okay? Team structure, we've talked about this ad nauseum in the past. Just suffice to say, you're always working towards getting more members than you possibly can up to a limit. But usually there's a half-life. Some teams are a little different, but anywhere from a month to 2 months is the team falls in half in terms of number of participants. All these eager students come in September or August, and by October, it's like where they all go. And then comes Christmas time, where they all go. There's a core group of you that are working so hard. What's interesting about that is in some organizations, they do the opposite. They start with a small team, which I call kerneling. You start with a really small group, usually veteran engineers. They get the concepts together, what's going to be done. And then as they flesh out and approve the requirements, the team builds and builds, but based upon a fundamental set of requirements. Okay? If you've got team members who are working on it and they start disappearing, that knowledge base of the requirements that they're holding in their head or in their notebooks is gone. Okay, so it becomes a bit dysfunctional. The other thing about teams and communication, basic communication theory often suggests the more often you can communicate, even if it's lower amplitude, talk a little bit more and don't say so much in a given particular get-together, all right? Otherwise you forget it. Okay, so rather than high amplitude and cover everything and do it once, better to have several meetings at times covering just the items that are necessary. And there's a balancing act there, of course. Technical memory, you've heard all of your judges, I'm sure, told you. Take good notes of what you've done. When does next season start? Right after you leave tonight. When you're in the truck going home, okay, on your way to the hotel or to the campground, you're thinking about how the car's going to be better, okay? Some of you have started it before now, okay? Don't wait till September. That's a bit late till you get your requirements together. And you got to train the new people coming in. Okay, so I'm talking about some product development stuff. In my previous history in consulting, I used to go to the major automotive installations and look to see how engineers interface with each other, and everything from military as well as automotive and others. One of the problems we run into is the requirements keep changing. Marketing says we need this, and then 6 months later they say, oh, no, we need this. Well, wait a minute, I have got something to take you several years to develop. Now this work I've done is no longer useful anymore, okay? So it's really important to get your requirements worked out and do your best to lock them down, okay? And related to that is, when should you start building your frame and the other parts of your vehicle? There's this rush, which we often call visual progress. And somehow we feel like we're making progress because we've got a frame. Well, what if 40% or 60% of that frame properly needs to have modifications done to it? Now you start building a hodgepodge. You're not going to go back and start over the whole frame, right? You're going to cut this here, you're going to add another triangulation here. Then you get a clarification from tech, who said earlier, oh no, we have to have a little more structure in here. Now you're cutting and rewelding this frame repeatedly, and you're no longer got a fundamental design. And that goes through more than just the frame, just more than the chassis. It affects the suspension, it affects a lot of different areas of the vehicle. You're often better, instead of rushing to do that visual progress, is pausing a little bit and get your energy focused on getting those requirements locked in. You guys are lucky. You've got a design time here of about 8 to 9 months, a little less, and maybe a month or two of testing. Ha ha ha, right? Some of you guys have tested all. And then we've got the competition, right? Well, in some areas, a product might take 2 or 3, or used to take 5 or more years to develop. And so the requirements you set up in 2022, by 2027, the world has changed. So there's a certain method of trying to compress that development process. And one way is keep the requirements, get them locked down, and try to not let them get changed too much, so keep them robust. Then you can get away with starting that prototype build just a little bit later, and you're less likely to have a whole bunch of massive changes have to be done, because whatever changes you want to make, you did them on paper, you did them on the CAD, in your various simulations before you actually started building it. Does that make sense? You don't want to iterate too much there. I'll show you some graphics in a second. Go to the next page. Okay, I know it's tough to see it here. Something I picked out of a document from many years ago. Just got me going this weekend to do it here. Sometimes we will talk about various functions that have to be done on the vehicle. You do a function, and then you pass it over to someone else, and they do their function. Pass it on to the next, and down to the next. Okay? And then hopefully it's all done, and we pass it on to, production, or we send it to the customer, whatever it might be. This is sort of how you usually have a manufacturing process. It's all kind of linear, all in one direction. Okay? Oh, but I got a little thing here. See this little feedback over here? Well, that's supposed to be telling the next year or the next, this is your design legacy feedback, an information line here, okay? So that the next year when they do this, they repeat these functions, they look everything they learned and come on back here. Okay? Sounds like a nice, easy process, doesn't it? Okay. This is a little bit more of what it really typically looks like. You do a function, you start passing it on, and then you realize they pass you some feedback back, and you say, oh no, we really meant to do something else. Hold off on that drawing I gave you over here, and we'll fix this, and then you go back and make your adjustment. Okay, if that's a matter of a day or so, you lost a day or so. What if you did this function, come down, they followed religiously what you said, go to another one, and now 3-4 weeks or 3-4 months have passed, and oh, by the way, a new requirement comes in, or there's a feedback that says, is this really what you wanted to do? Do you really want the throttle pedal over here on the left side? Is that what you're planning on doing? Oh no, the drawing was wrong. I gave you a mirror image of it or something. Okay, we got to go through and redo all these things. I just lost 3 months, okay? Your development time is typically 20 to 30,000 hours or man hours to do a fresh build, a fresh design. Some of you may be longer than that, some of you have shortcut it and made a lot less. If you can do this and get your requirements down right and have not so many big feedback loops to occur, you might find your whole development process can be down to 3 months or so. Okay? Sounds unbelievable because no one else does it. But if you think through, what are my requirements? Sometimes we say a simple car may actually be a more well-performing car, not because we want you to be simpletons, but because we want you to have something that's complete and you understand the systems well enough that when you have a problem in the field, you can fix it right away. Okay? And that is demonstrated when us judges ask you questions and you say, oh, well, the person that did that isn't here anymore. Where are they graduated? Okay? Or you got to go look it up. If you got to go look it up and you would lead on a particular subtopic, I would expect you to know most of these things off the top of your head that we ask about. But if the things kept changing on you, it's difficult to keep track of that. Okay? Next one, please. Oh, back up one, please. Left arrow. Here you go. You may be surprised, but in industry, on product development, 90 to 95% of your work is wasted effort. Think about that. How long would you last in a production environment if you're the production manager at 90% rework? You might last the first day, right? Yet that's normal for product development. In software development, it's even worse, okay? So be mindful of the fact that rework is a normal part of the design process because you're learning, you're refining, mistakes are made, you stumble. Better to keep these as shorter feedback loops that don't delay you so much because it's not just these little 4 functions. You may have a bunch of parallel functions going on, and all those people could be wasting their time too if it's a big enough change. Okay, we can go to the next one, please. This is for an actual organization. It's a very high-level view, and in each one of these, there were another 700 functions within that. Okay, something like a tunneling in type thing. Look at all the feedback loops going on all over the place. Think about something. If you're an organization that's got several hundred people, and this one back in the day had 800 people as design engineers, and you work over here in this section, and there's maybe 500-600 other functions that occur, okay? So maybe another 150 friends of yours. How well do they know what's going on over here? Very difficult to keep that coordination when you've got so many people doing it. So in a lot of cases, you're better off with smaller subsystems, multiple subsystems, rather than one giant group that doesn't really coordinate within very well. Well, this was an actual one. I spent almost 2 years going through studying with an organization that's, well, I won't say with how many 100 miles away from here, but pretty close. Okay, next please. Okay, now this is near the end of this. I know I didn't say there'd be any math in this exam, but if you've got 2 people involved, how many interfaces do you have? 1 or 2 if you're talking back and forth to each other, right? The relationship here is basically n squared minus n. So generally speaking, the more people you have or the more components you have on your system, it's going to go up with the order of the square of this number of components. Sometimes we will call the number of components more complication. But the number of interfaces is going up with the square, okay? That's when we start to say, hey, this is getting really complicated from a communication. If you've got all this looping going on, now it becomes complex. Okay, so we used to characterize it as being chaotic, okay, mathematically. But how are you going to communicate when you got a whole case here? This is just 6 of you on the team. You've got up to 30 communication channels. If you've got 15 of you on a team, a lot of you do, you've got 210 communication channels between each other. You've got to work to manage that. Now, I know you're not all going to be on every single channel here talking to each other every single time, but you have to have the provision for that, okay? Keep that in mind. That's very, very much overlooked in management. They tend to think that, well, we just make it twice as big, or twice as many components, we'll just put twice as many people on it. Well, good luck trying to manage that. Okay, this shows the more you try to be concurrent, try to do multitasking together, You get an area where it becomes very difficult to manage it. When you don't have a lot of concurrency, it's very easy to manage. Most operations are operating right around here somewhere. So a new manager comes in and jumps up in this region because they're going to make everything better. Okay? And then we have problems in the future. Okay? Next. This is also a similar thing. I should back up a second. This is, the upper line is kind of like how capable you are. You've got better CAD systems, you've got better information transfer. Oh, we invented an internet so we can talk even faster, we've got better CAD programs. That only goes up at a more moderate rate, but the amount of complexity goes up even faster. Okay? Okay, next. All right, the other thing is, if we try to do everything at once, it actually causes us to almost, you ever heard the word fibrillate? Your things are just rapidly pulsing to like atrial fibrillation with hearts and so forth. Well, we can have that happen in organizations where you're talking back and forth, but you're not really communicating. It's not really getting through, okay? Or the message didn't get through, it got dropped. And then you spend more time trying to diagnose your communication channels. Okay, where's that email? Where's that particular? You sent me a text. I didn't see it. Oh, it was on there. Well, it was on Pinterest. Oh, that's why. Okay. The idea is be careful about trying to do things so quickly and so much in parallel that you can make it outside of your capability of managing it. Okay? I'm covering some pretty high-level stuff here that most managers don't even understand. This is the dynamics of how many of your organizations work. Okay? And you are a microcosm of that. You are so lucky to only have a relatively small number of people on the team because your communication lines are relatively limited and relatively short. Take advantage of that, but realize when you go into industry, you may never know other people who work on the same project you do. You may never get to meet them. And they're going to be using your drawings or your design. Okay? Until they have a problem 8 months later, but you forgot that part of the project. Okay? Next slide, please. Okay. As I talked before, product development is a really difficult task. If you're doing something fresh, it's very difficult because the complexity, all of that feedback loops that are going on is very high. If I simplify the process, I can come over here to more routine development, okay, or even large-scale manufacturing where we've nailed it down to be very, very routine over and over and over, okay? Then it's just difficult because there's a lot of items to coordinate. When you got to coordinate and the process itself keeps changing on you, remember this is over here, this is your 0% rework, this is your 90% rework, and you're trying to operate over here to come up with something new. Usually what you end up doing is not being successful here and working back down here closer to the center of this matrix, okay? Out here, this is where your inventors work. They work all by themselves, okay? They come with some super complex deal, but it's nothing anyone else understands and no one else in the world can talk about it. That's your research labs. Okay, and this is your regular assembly operations that anybody can do. Don't need much education or knowledge to do that stuff, okay? So you're trying to work up out in this region, okay, and be successful, and you just made your life tougher. Hey, that's what you get for getting a great education. Now you get to do the tough work. All right, next one, please. Okay, Steve.
Are we on? Good. We're going to talk about 3-view drawings. We do judge all of the 3-view drawings. Some of them are pretty darn good. Some of them aren't done real well. So per the rules, your 3-view drawings are supposed to be turned in on 3 separate pages. So your 3-view drawing should be a 3-page document. We saw 1, 2, 3, and 4-page submissions this year. The only ones that get judged are the ones that are 3-page documents. And we do have it ranked. Next slide. So an honorable mention is 57 University of Alberta, 251 McGill, 27 UC Berkeley, and 229 Madison, and 281 Ontario Institute of Technology. These are like rounding out the top 10 of the best 3-view drawings that we've got. We print the 3-view drawings on a vinyl poster. We put them up in the design building all weekend, and feel free to come in and look at them and see, the best of the best. These are the students that you're competing against. The 10 best drawings are up on the board. The top 5 3-view drawings are as follows. Fifth place, hold up. Don't push my buttons. 5th place goes to 36, University of Southern California. Fourth place goes to 241, Georgia Institute of Technology. Third place, 52, Rensselaer Polytechnic Institute. Second place, 277, Western University. The best 3-view drawings that we saw this weekend belong to number 250, University of New Mexico. Thank you very much for the great job that a lot of you did on the 3-view drawings. The top 10 teams, their posters are here on the stage. Come up after this presentation and collect your poster. It's yours to take home. Thank you very much. Okay. Hold up there. No, you can push the button. You pushed it. You let it out of the bag. Let it out one more. There we go.
All right, these are among our finalists that we just got to have fun talking to you for 2.5 hours last night, 3 hours actually. So yeah, 6th place. By the way, making finals is a phenomenal task. We really try to find the creme de la creme of the teams that are here, which is usually a first break of around 10% of the teams. This year in internal combustion engine, we actually had 6 teams that we had to be in that category, and they were pretty much distinctly above the rest, and the score sheets tend to show that as well. So hats off to all these teams around here, and you'll see. Okay, that's it for now. So,
is yours working? Okay. So 6th place in design in internal combustion is number 27, University of California, Berkeley. Fifth place goes to 102, North Carolina State, Raleigh. Fourth place goes to 48, University of Texas at Arlington. There's no hardware for these guys, but they did a hell of a job. They presented a very well designed and executed car. They are very worthy of being in design finals. We had a good time talking with them last night. All of the teams presented their cars extremely well. First, second, and third place do get a little piece of hardware.
more like a shot glass than a beer glass, but yeah, we want to just point out here that any one of these, here Raleigh, for instance, made it to finals last month, in fact. So they repeated the performance, even after they had made it through notifications and so forth. So they were able to back it up. So in Texas, Arlington, they're the ones we mentioned that had the wing that would go directly to the unsprung weight. Okay, so they did some good work here, and they, like I said, they should all be applauded very well. But now we're into the top three here. Go right ahead, sir. San Jose State.
Come on down. Come on down. San Jose State, come on down. Awesome job. San Jose.
Little delay. Okay. Okay, so we're going to go to the top two. If you go ahead and switch the slide, please. One more. Okay. The top two were pretty darn close, and I put this slide up here before showing it to you yet, because when we compile them, we had, I think it was 42 judges that were at finals last night, our senior judges that have been around the block a few times and seen all kinds of stuff. The team that had the highest score, we ranked them all 1 through 5. The team that had the highest score on average for everything, obviously would be our first place team. But it turned out the second place team actually had more of the first place votes. So there are more judges in their respective areas that actually went for the second place team. The issue though is that the second place team also had a lot of low votes as well. Okay? So what that means is we had kind of a polarity here. They kind of either loved it, I wouldn't say they hated it, it was still a finals car, but they thought it wasn't really worthy of winning, okay? So what that tells you is that though you can be very proud to say, hey, I got more first place votes than anybody, you know, Babe Ruth struck out a lot too, right? There are things you can fix on your car or improve, and this team, if you talk to your judges this afternoon, you know a lot of those areas. So if you could hit that once, please. Purdue University, congratulations.
Come on down if you're in here, Purdue, come on up. Thank you very much, Purdue. Great job. Leaves one last piece of hardware to give out, Dave.
Yeah, let's see what we got here. Oh, this one looks more like a Stein. Here we go. Who wants to drink out of this cup here? University of Champaign, Illinois.
Your first place design winner, 2022, University of Illinois, Champaign-Urbana.
This is getting to be old hat for you guys, isn't it?
Congratulations, guys. You did a great job. Thank you. Great job. Thank you, Illinois. You deserve it.
Out for a more shocking experience.
Little humor, very little humor, Dave.
What was I going? Okay, so our honorable mention teams, again, these are all finalist teams that we have to see last night. And they all were exemplary in their demonstrated knowledge. One thing I do want to mention again, I mentioned it on Wednesday when I saw you all, is we're not really here to just look at how great your car looks. Remember, we're looking about your knowledge base of things, okay? So all of these teams that made it to finals, we were actually quite impressed with how well the teams could come up with an answer on just about any question we had for them, okay? And, you know, so that goes a long way. And it's depth, too. You know, well, our main guy here doesn't have it, but this other guy who's our number 2 can fill in, and their answers were about as good as I could have ever expected. And our judges back that up as well when it comes to the finalist level teams. So, in 5th place, we have University of Pennsylvania. In 4th place, Georgia Tech. Okay, so we only had 5 teams that were in finals for the EV cars. So the next one here will be our first podium winner is a third place team. And that team is Michigan Ann Arbor. Coming up for your jewelry, your trophy.
Ann Arbor, you in the building? Come on, guys.
All right, so here it was kind of fit more like we might have expected in terms of the first place votes. It was a little bit more consistent, but there's still pretty darn close total tally here. So the second place team here went up with 145 out of 150, so it's still pretty phenomenal. And that team is Carnegie Mellon.
Carnegie Mellon, second place design. Thank you.
Okay, so our first place team for the EV competition is ETS.
Okay, everybody jump when we do the stage test.
By the way, all the cars that were the top 3 finalists for EV as well as internal combustion were all parked out here. The 2 of them, Michigan and Carnegie Mellon, were late because they were still stuck in tech after the endurance. So before you go, you may want to take a quick look at that. I don't know where we stand with the ceremonies, if we're ready right away, or is work complete? What's that?
Yeah, we'll take a little break. I've got to give these folks some stuff. The lost in time for the part where you took and didn't give back. So do we have a representative from Road? Thank you to all of our family and friends and our loved ones and our faculty advisors. I know it's been a tough year too for a lot of us. I think everyone deserves a big hand. You know, we rely on those teams around us to help us make these things possible. Also want to give a thank you to our sponsors. So we have ABB, Actolin Services, Altair, BAE Systems, BASF, Blue Origin, Bosch, Cummins, Daimler Truck North America, DS SolidWorks, Go Engineer, E-Controls, FEV Incorporated, Ford, Fox Factory, General Motors, Hermeus, Honda, Hoosier Tire, Lucid Motors, Magna, Mala, MathWorks, Multimatic, Nissan, Rivian, Siemens, SpaceX, Stellantis, Tesla, and ZF. So let's give them all a big hand. Without their support, it's much more difficult to put events like these on. Now, some of these sponsors have put together special awards for special projects, special goals, and to start off today's presentation, I'd like to invite Jackie Zimney up to present GM's Everybody In Award, along with Mark Scott. Big hand for Jackie. Thank you so much.
Thank you, Alton. Good evening, everyone. As Alton said, my name is Jackie Zimney. I'm a System Integration Engineer and the Baja and Formula SAE Recruiting Lead here at General Motors. I am a Formula SAE alumna, and it was here at the Formula SAE Michigan competition a double-digit number of years ago almost, that I launched my own career at GM by talking to a GM recruiter at the GM tent like many of you did today. I have the pleasure of presenting GM's Everybody In Award tonight. Just like each one of you, GM knows that the time that you spend engineering a race car with your team is immensely valuable. We have been there. It's been a long week. I've been saying a lot of words. We've been there, we know what it takes, and we know what kind of experiences go into building a multidisciplinary team, overcoming design challenges, and coming together to compete in a world-class environment. And so we want to recognize what you and your teams are doing to engineer the future. The Everybody In Award grew out of our desire to make meaningful connections with students and teams while also sharing the values of our Everybody In campaign. Those are safety, engineering a zero-emissions future, and social impact through inclusion. Embodying the spirit of Everybody In goes beyond just building a race car. We envision that the team who receives the Everybody In Award demonstrates the following core behaviors: a pervasive safety culture, a commitment to reducing emissions by seeking out efficiencies everywhere, and a persistent good faith effort to be inclusive of everybody in and around the Formula SAE community. And we received many responses speaking to many of those qualities, but one submission stood out from the rest. This competition's winning team demonstrated the entire team's commitment to the pillars of everybody in. From the newest team members to their advisors, this team is committed to safety in everything they do. They emphasize the intersection of safety and education by conducting structured machine shop and hazard safety specific training and welcoming new team members through a mentorship program, regardless of their knowledge and skill levels. The whole team is excited about an all-electric future and sharing lessons learned through their first EV iteration with future teams by building a team wiki and knowledge transfer system. And finally, even as one of the largest organizations on their campus, one of the team's priorities is breaking down barriers to entry and engaging with the entire university community through automotive-related events and cultivating a welcoming learning environment for everyone and anyone. And with that, it is my pleasure to announce that the winner of the Everybody Award is Columbia University in the city of New York. I know we have someone on site. There they come. Come on up. Back to you.
Again, a big thanks to GM, and congratulations, Columbia. Up next, our friends at Cummins would like to present the Cummins Innovation Award. To do so, I'd like to invite Chief Operating Officer Jen Rumsey up to the stage to present the 3 awards from Cummins.
Thanks, and great to see all of you. I've known for many years about Formula SAE, but this is the first chance I've had to actually attend a competition. It's been awesome to see over the last few days. And Cummins is proud to sponsor the Innovation Award, and I think SAE is an excellent opportunity for you to develop your engineering, teamwork, and innovation skills. I'm the Chief Operating Officer for Cummins, but I spent much of my career in our engineering organization, including Chief Technical Officer. Before moving into this role, and innovation is especially exciting here because I see work in both internal combustion as well as electric powertrains, and Cummins is investing in both of those, which we think are critical to decarbonizing our industry, commercial and industrial equipment like trucks and buses. So I am here today to present 3 awards, and despite the fact that I'm wearing a Purdue hat, for those of you that may notice, Purdue will not be receiving any of these 3 awards. Sorry, Boilermakers. I do want to thank all the teams that applied. And in 3rd place for this competition, we have Bradley University Internal Combustion for their application of a supercharger. Is Bradley still here at the competition? Okay, we'll get that trophy to them. In 2nd place, we have University of Calgary Internal Combustion Team for their self-created web-based telemetry system. Is University of Calgary here? And in first place today, we have Carnegie Mellon University, EV, for their new member lecture series and accumulator design using single-sided interconnects and thermal epoxy. Congratulations, Carnegie Mellon.
All right, thanks Jen, and thank you Cummins, and congratulations to all the winners. SAE is going to be presenting on behalf of Siemens Software the Digital Twin Electrical Engineering Excellence Award for Formula Electric teams. Siemens was very pleased to receive outstanding applications for this award. They thank very much all of the teams who applied despite the difficulties of the past season, such as the pandemic. Why digital twin? It's very simple, really. Every top-tier Formula student team in the world uses digital twin-style methodology to a major degree, with a simulation-centric feed-forward feedback process. We encourage every team, even if you don't apply this year, to look at the Digital Twin Award Notice, which has valuable tips to grow your team's sophistication and competitiveness in future years, whether you're combustion or electric. Siemens was impressed with all the applicants' understanding of the digital twin methodology. First, they want to recognize and honor a team with an honorable mention for the thoughtful architectural approach to their electrical system. So let's give a big hand to the University of Toronto Formula Racing. So now we find out the Digital Twin Electrical Engineering Excellence Award third prize, which comes with a prize of $1,500. This $1,500 prize goes to North Carolina State University Raleigh Pack Motorsports Formula Electric team. I don't think we have a physical trophy, but come on up, and I think the check's in the mail. There's no trophy for Siemens, right? I do not see it. Okay, I'll make sure we get you the trophy. You can't leave the paddock without it. So I'll give you a handshake. Yeah, there you go. No, it's good, it's good, it's good. I wouldn't want it either. The check is the important part. All right, congratulations, NC State. The second place prize comes with $2,500. And that $2,500 Digital Twin Engineering Excellence Award goes to the Formula Electric team from McGill University. You want a handshake? Okay, and you dropped your radio, I'm sorry. Great. Now, the first place winner of the 2022 Siemens Digital Twin Electrical Engineering Excellence Award. This comes with a $3,000 prize. Now, this team achieved a high degree of efficiency and value from their digital twin models while using the entire suite of Siemens software, which also helped to overcome project stresses, for example, handling staff turnover. Also, they took great advantage of software-enabled integration of the electrical system into the monocoque chassis while lightweighting the high-voltage wiring harness. Please give a big applause to the top digital twin electric expert team for FSAE 2022, a truly international team, Global Formula Racing at Oregon State University, partnered with Germany's DHBW Ravensburg University. Congratulations. Thank you. Siemens wants to suggest that both your electric and your combustion teams consider a no-cost grant of Siemens tools for your own digital twin improvements for next year. Again, one last round of congratulations to all of the winners. Now, up next, I'd like to invite up to the podium for discussion of a very special award for a lot of us who have been involved with SAE for a long time, the Carol Smith Award, Dr. Peter Jones. Dr. Jones.
Okay, thanks folks. Thanks Alton. Let's see, I was Auburn University's former faculty advisor, and just like you guys, after you get out of formula, you get to come back and be volunteers. And so I'm off the working hook and back on the volunteer side in design judging. I'm here to report on the presentation of the Carol Smith Mentors Cup. So let me define Carol Smith, mentor, and the cup. Carol Smith was the preeminent race car engineer of his generation. He was the engineering manager for the GT40 Le Mans victories in 1966 and 1967. He wrote Prepare to Win, Tune to Win, Engineer to Win, Drive to Win, and Nuts, Bolts, and Fasteners. Most importantly, as FSAE Design Chief Judge from 1993 until his passing in 2003, actually during competition. He wasn't there, but it was those days. He enabled the expert learning tool that Formula SAE Design Event has become. This style of student project judging, you're not going to find it anywhere else. Mentor means your faculty advisor. The advisor's role is to maintain continuity in the team over the years, create an environment for learning and doing, take an active role in promoting the team, and personally mentor the team members. Note that by FSAE Rule AD.5.1.3.B, faculty advisor must not design, build, or repair any part of the vehicle. The advisor needs to know when to stay close and when to back off. It's a kind of a tough line to stay on. The cup is offered by SCCA, the Sports Car Club of America, in order to serve Carol Smith's recognition that the best teams, as averaged over the years, are those with the most effective faculty advisor. The cup seeks to honor these advisors. The cup has been awarded every year since 1999, although we missed 2020 for obvious reasons, and 2021 because I guess we had, big graduation loss and had a tough time getting the team back together again. We've reinstated it now. Past winners that are attending this competition include Cliff Stover in 2017 from Cal Poly Pomona. In 2015, John Russell from the University of New Mexico. In 2011, Bob Pash from Oregon State. And 2006, that was me. So, it gives me very great pleasure to honor this year's winner, one of the truly great Formula SAE faculty advisors, Dr. Ron Matthews from the University of Texas. Who, unfortunately, is not here this evening. Dr. Matthews has the same problem balancing family, professional, and Formula SAE needs as everybody else does. He promised his daughter he was going to be home for Father's Day, and he held true, and he's on a plane right now. So, but once again, folks, I think Ron Matthews is really one of the key recipients of this award. Now, let me give a little advertisement here. The Mentors Cup winner is selected by a committee of past winners, but depends upon nominations from the teams. Nomination directions going forward will be posted on FSAE Online this summer. If your advisor has been doing a great job over a long time, we really hope to hear from you. So, folks, thanks very much.
Thanks very much, Peter. Okay. So we'll start handing out the hardware with a little bit of discussion of the cost event. If I can find my cost event page. Hold on. Shuffle, shuffle, shuffle. That's what I expected it to be. Sorry. Pro tip, avoid getting a stack of things in the middle of a presentation. We'll talk about that when we talk about presentation. So the cost event focuses on your ability to design and build a vehicle at low cost. We'll start with discussing the winners in the internal combustion class, and then we'll move to our winners in the EV class. In the internal combustion class, in third place, our winners are the University of Texas at Arlington. Second place in cost for combustion vehicles is the University of California, Berkeley. And your overall winner for the cost event for combustion vehicles, the University of Illinois at Urbana-Champaign. On the EV side, third place in cost, Cal Poly State, San Luis Obispo. In second place in cost for EVs, Georgia Tech. First place in cost for electric vehicles goes to McGill University. Unexpected plot change. We're good. The presentation event, we'll start with the EVs and we'll move to IC. And you'll start to get a feel for it. So for the presentation event, in third place for electric vehicles, the University of Washington. For EVs, second place in presentation goes to Carnegie Mellon University. Congratulations. And the overall winner for EVs in the presentation event, Ryerson University. Over on the combustion side, we also have 3 winners. In third place in presentation for combustion vehicles, the award goes to Iowa State University. In second place for presentation for ICs, Cal Poly Pomona. And in first place for presentation on the IC side, the University of California at Berkeley. Up next, I'd just like to briefly remind you of our winners in the design event if you weren't here at the design presentation. On the IC side, in third place, San Jose State University. In second place for ICs in design, Purdue University West Lafayette. And the winner in design for ICs was the University of Illinois at Urbana-Champaign. Among the EVs, the third place design event winner was the University of Michigan at Ann Arbor. Second place went to Carnegie Mellon University. And the overall winner in design for EVs, École Technologie Supérieure, ETS. Well done to all of them, and I hope you got to enjoy the presentation. It was really special. Over to the dynamic side, we'll start with the acceleration event, which is presented in partnership with Stellantis. We'll start with the EVs and we'll move to the ICs. In acceleration for EVs, in third place, Georgia Tech. Second place in acceleration for EVs goes to Polytechnique Montreal. And the overall winner in acceleration for electric vehicles at Formula SAE Michigan, June 2022, Oregon State University, Global Formula Racing. For combustion cars, third place in acceleration goes to The Ohio State University. For internal combustion cars, second place in acceleration goes to San Jose State University. And the overall winner in Excel for combustion vehicles, University of Illinois at Urbana-Champaign. For skid pad, we'll stay on the IC side first. If I can find the trophy. There we are. Third place for skid pad for IC cars goes to Cal State Poly Pomona. Second place in skid pad for combustion cars, the University of Illinois at Urbana-Champaign. And your winner for skid pad, for June 2022 Michigan Formula SAE, Purdue University West Lafayette. Skid Pad third place goes to Georgia Tech. In second place in Skid Pad for electric vehicles, Oregon State University. And your winner in Skid Pad for the EV class here at Formula SAE June 2022, the University of Michigan in Ann Arbor. We'll stay over on the electric side to start our presentation for autocross presented by Magna. In third place in autocross for EVs, should have just had them stay up here, it's the University of Michigan in Ann Arbor. The second place EV in autocross, Polytechnic Montreal. And your winner in autocross for EVs, Oregon State University Global Formula Racing. Magna sponsored both sides of the autocross event. So your IC winner, or third place winner for autocross is Purdue University West Lafayette. In second place in autocross for ICs, NC State at Raleigh. And your overall winner in autocross for IC cars here at Formula SAE June 2022, the University of Illinois at Urbana-Champaign. Now, as you know, our fuel efficiency and endurance events are run together, and they are both sponsored by Ford. So, because we have 2 events and 2 classes, we have 4 sets of trophies. We also have 4 individuals from Ford up here to help us present them. Mike, Brian, Tony, and Trevor, all from Ford, will help me to not have to walk across the stage so much. All right. It's okay. So we'll start with fuel efficiency for ICs. Got it? Got it? All right. There's a lot of hardware up here, yeah. All right, for fuel efficiency, in 3rd place for internal combustion vehicles, University of Wisconsin at Platteville. Okay, yep, we'll send that to them. Can't make my podium too full. 2nd place in fuel efficiency for IC vehicles goes to UCLA. Okay. Hopefully they're here to receive it. Our overall winner in fuel efficiency for combustion vehicles is California Baptist University. Over on the EV side, we also have a set of energy efficiency winners. So 3rd place in energy efficiency, fuel efficiency for EVs goes to Carnegie Mellon University. For EVs, our 2nd place finisher in overall efficiency is San Jose State University. But the overall winner for efficiency for electric vehicles is the University of Texas at Austin. Congratulations to all of our winners. Now it's time to move on to the big one. 22 kilometers. For the endurance event on the EV side, in third place, the University of Texas at Austin. Our second place finisher in endurance for EVs is the University of Michigan in Ann Arbor. The overall winner for the endurance event in EVs, presented by Ford, Polytechnic Montreal. Congratulations to them and everyone. Over on the IC side, we have a different set of winners, obviously. And the third place winner in the endurance event is the University of Texas at Arlington. For combustion vehicles, second place in endurance goes to Purdue University, West Lafayette. Now, the endurance event is tough on both sides, and so the overall winner of the endurance event for combustion vehicles is the University of Illinois at Urbana-Champaign. How about one more big round of applause for all of our event winners? But I think, as we all know, it's not about winning just one event. It's about scoring points in every event, showing a breadth of preparation and knowledge and skill. And so the Spirit of Excellence Overall Award winner, we have 3 trophies for each, third, second, and first place, but we'd like to acknowledge the top 10 finishers in each category. So I'm going to start on the IC side and move to the EV side. But before I do that, I want to cover a couple of things. As we wrap up here, it would be a huge help if you folded up and stacked your chairs. We say it at every event, and you tend to do it at every event, and it helps us out big for getting this place packed up for the night. So if you'd pack up your chairs, stack them up. Stack them up over there. Okay. I always forget where they get stacked. I don't know. It's been a long week. Been a long week for everyone? Yes. Okay. So you want me to finish? Sorry? Oh, there's a free beverage over there. We're incentivizing. There's beverages over there. We're not going to tell you what they are, but they're probably cold and tasty. Second thing is, please help our event crew get MIS back into shape for the other events that happen here. Please clean out your paddock before you leave. As you pack up your trailers, take all those loose bits of trash, throw them in the trash bin, tie up your trash bag, and leave it at the front of your paddock on the number. Please don't leave us the big stuff. No big metal pieces, no small metal pieces, no big cardboard. Please don't leave us carbon fiber. We can't use it. Also, and this is something Dr. Jones mentioned and others have mentioned, I want to encourage you on behalf of all of the volunteers, especially the alumni volunteers, if you're graduating or if you're going to be graduating next year, start thinking about making a plan to come back and volunteer. I think for those of us who come back as volunteers, whether we're event crew, or we do timing and scoring, or we do design judging, or we're reviewing one of the various presentations, it's a really rewarding experience to give back all of that educational gain that we receive from Formula SAE. We pass it on to the next generation. So I want to encourage you to come back and do it again without the additional pressure and sleep deprivation and, long drives through the night. It's a lot more fun. So please consider coming back. It's a great time. On that same note, the sleep deprivation thing, please drive home safely. Take your time, check your trailers, check your tire pressures, all that good stuff. We want to see you back here in 2023 for more fun at Formula SAE. With that in mind, the app will push out notifications as the 2023 schedule goes live. So dates, locations, registration deadlines. Now before I present the overall winners, just like to invite Kaylee Zindel up very quickly for a quick, you good? Did you have anything else to say? It's okay. Do you have anything else to say to them? Thank you to all of you. How about you give yourselves a big round of applause? It's a tough week out here, and you all did a great job. One last thing, are there representatives from ETS here? Is ETS on site still? Yeah. If you could have someone run over to E-Tech, that'd be great. I just got a text. So send one person over to E-Tech. I think it's about the E-meters, that's all. Okay, the overall winners. We'll start with IC, we'll go to EV. So we'll read 10th through 4th, and then 3rd, 2nd, and 1st we have trophies. But let's acknowledge briefly all the achievements of 10th through 4th. In 10th place overall, we have the University of Texas at Austin. In 9th place, Cal Baptist University. In 8th place, UC San Diego. In 7th place, the University of Nebraska at Lincoln. In 6th place, NC State at Raleigh. In 5th place, UCLA. In 4th place, San Jose State University. I don't want to knock stuff over, so I'll move here. Okay. Okay. I was confused by the bases versus the sizes. I thought I was not reading correctly. Okay. In third place overall for combustion vehicles, the Spirit of Excellence Award goes to the University of Texas at Arlington, UTA. For combustion vehicles, second place overall goes to Purdue University, West Lafayette. And now, I'll give them a second to take their seats. It's heavy, I'm doing curls. I won't break the trophy, I promise. For combustion vehicles, your Spirit of Excellence overall winner for Formula SAE June 2022, the University of Illinois at Urbana-Champaign. How about one more big round of applause for all of our combustion side overall winners. Now over on the EV side, we have another great set of teams. We'll do the same thing. We'll go 10th through 4th overall. We can all acknowledge their achievement, and then for 3rd, 2nd, and 1st, we'll come up against some hardware. In 10th place overall for EVs, McGill University. In 9th place overall, UPenn. In 8th place overall, San Jose State University. In 7th place overall in EVs, the University of Texas at Austin. For EVs, 6th place overall is ETS. Fifth place, Carnegie Mellon. In fourth place overall for EVs, Oregon State University. The overall third place Spirit of Excellence winner is Georgia Tech. See, normally I'd be trying to fill the dead air, but it's been a long week for everyone, I think. You've heard enough of my voice. So, I think all that's left to do is for me to acknowledge the second place finisher overall for electric vehicles, and that is the University of Michigan, Ann Arbor. And so, after a week of lightning and wind and cold and heat, and basically all of the Michigan seasons all in 1 week, which is like a normal week here, we come to the last trophy, but certainly not the least trophy. Your overall winner, the Spirit of Excellence Award for Electric Vehicles at Formula SAE June 2022, goes to Polytechnic Montreal. All right, everybody, I think everybody deserves one last big round of applause. Thank you all so much. We'll see you in 2023. Have a great trip home. Goodbye.